Okay, good afternoon. Welcome to
FamilyMath number 294b.
294b. So I got this book that was recommended on Twitter the other day. It's called Patty Paper Geometry. And patty paper is I've never heard of it before, but it's kind of this paper. It's transparent. Can you see through it?
Yep.
And they have you studying geometry using this special kind of paper. And so I picked a section about perpendicular bisectors of triangles. And you and I have not ever talked about perpendicular bisectors before, have we? So we're just going to see what happens. So step one isn't too bad. Draw a large, acute, scalene triangle on your patty paper. So what does that mean, first of all? Do you know what an acute triangle is?
Well, it's a triangle with angles. It's a triangle with an acute angle in it.
How many?
Isn't it all?
All the angles are acute. And do you know what scalene means? Have you ever heard that word before?
It's all the sides are different.
Okay, awesome. So you're going to use this as a straight edge to draw some straight edges of your triangle. And make sure all the angles are acute, and make sure all the sides are different. I can help you hold it.
Let's see, there's one. And we can make it like this.
Let me make sure I hold this down for you.
What if we made it like that?
Okay. And then this one goes here?
That kind of.
Well, is it lined up right? Okay.
It looks like it has a right angle in it.
Well, it's close enough. Would you do me a favor also, just to make it show up better on the camera? Can you fill in just some small dots where the corners of the triangle are? Just some small ones. That'll just help it show up better on the camera. And then what I want to do is zoom in a little. Okay. Perfect. Now, step 2 here says, fold to construct the perpendicular bisector of each side of your triangle. Now, perpendicular bisector. What does that mean, do you think?
Well, I think it's something to do with something that's perpendicular to the side of a triangle.
Okay, and what do you think a perpendicular bisector does to a side of a triangle?
Well, maybe it cuts it in half.
Ah, interesting. So we're looking for a perpendicular line that cuts each side in half. But not with a pencil. We're going to fold to do it. So put your pencil down, and we're going to try to fold and just figure out how can we make sides that are perpendicular and cut each side in half.
Let's see.
Now don't crease it until you're sure you've got it.
Does that look that looks right?
Well, let me see. What do you want to do? Move your hand back?
That.
What are you trying to do here? Which side are you trying to cut in half?
This one. This side. I'm trying to cut it in half. So.
This side here?
Yeah.
Okay. So we're going to try to make a line in the paper where that side gets cut in half. So what line is cutting that side in half right now?
Well, it's right. Isn't this kind of where this corner is?
Okay. Now, but that line is going to be this edge, right? So we want to actually fold it so there's a line folding through that middle bit.
Does that look right?
Well, what's going to happen when you let go? This part goes all the way back over here.
Yep.
This is tricky to figure out. Like, what's going to happen? How can we cut this side in half? What do we have to do?
Well, one way is to guess, but there might be another way.
Yeah, one way would be to guess, but I think something special happens when you. There's something special about the middle.
Maybe this point reaches that point.
Oh, let's see what happens when you do that.
Let's see. It's that.
Okay, what's going to happen when we fold this down now?
Well, it'll be cut in half.
Since why?
Oh, since this point is reaching that point, so this crease will be the half.
Okay, so let's make a good crease here. Maybe put your finger out like this. And then...
Trace it like...
Okay.
There.
Is that a good crease? Alright, let's unfold it and see what happens. Hey!
Looks like it's cut in half.
Okay, so that's one side cut in half.
So now maybe we should do folding this side over here. And that's lined up, right?
Is it?
Yep.
Okay, so give me a crease kind of come out from the sides here.
Like this.
Alright, and then once we've got a good edge there, give it a good crease down. Okay, let's see what happens.
And that looks exact.
Alright, awesome.
So now we need to do it for this side. So let's fold it like this.
Okay.
Can we kind of see where the dot is?
Can you see it?
I think it's right about there.
Okay.
So let's see.
Nice, nicely done. Okay, so there's all three sides. Alright, why don't you unfold it?
There's these perpendicular bisectors.
Okay, so now how many perpendicular bisectors did we make?
We made, I think it was 3.
Okay, cool. So now it says what seems to be true about the perpendicular bisectors. What do you notice now with this piece of paper?
Well,
I gotta hold it down here.
You kind of cut it into 4s with these crossing lines, and there's a point in the middle where all the perpendicular bisectors meet.
Whoa, is that surprising?
And it's right on one of the edges.
Yeah, it's right on one of the edges for this triangle.
Yeah.
And this turns out this is kind of a special triangle.
Looks like it's a 30, 60, 90.
It might be a 30, 60, 90. That'd be cool. It might be. Are you surprised that these perpendicular bisectors all seem to meet at one point?
Yeah. Looks. Though I also see something else.
Okay, what do you see?
These are right angles here.
What are right angles?
See this line? These angles. This is a right angle here.
Oh yeah, yeah. That's interesting.
I wonder if it's always true.
Well, maybe we should do a second one where we make this angle
different.
Because they said make sure it's acute. And this angle is pretty close to 90 degrees, so maybe we should do one that's got another angle. But there's one other interesting thing about this point where they all meet. Should we draw it in?
Okay.
You want to fill it in, this point where they all meet? Something really special about this point. It's a little tricky to see if you've never seen it before. But that point has a very special property.
Well, you can fold along the point and it'll create the perpendicular bisectors.
Well, that's true. That's how we found that point.
It kind of creates more triangles and quadrilaterals.
Yeah, it does.
Okay.
They all kind of meet there. But why don't we see how far away that point is? It says use your other patty paper from one of the edges, from one of the vertices of the triangle. So we go from that corner to there. Why don't you mark that point with a pencil?
It's about here.
Okay. Now let's rotate around. And we see how far it is away from this other vertex over here.
It's about the same.
Huh.
Maybe, and then if we rotate it there, then it's the same.
Hey.
So
that point has a really special property.
Yeah.
Which is what?
It's equally far away from all of them.
It's equally far away from all three of the vertices of the triangle.
Yeah.
And that means if you draw a circle whose center is there, you can make a circle that goes all the way around the triangle.
Cool.
Cool.
Yeah.
Do you want to try it with a different triangle and see if they all meet it in the same place again?
Sure.
Okay, well we can use this piece of patty paper.
Okay.
Alright, let's do that for our second video.